my research currently. This is just a part of our research right now. It is covered by Blackhole and Compactification solutions of Noncanonical global monopole in four-dimensional space-time. The introduction is as follows. Global monopole is something that can exist by considering its topology. It is non-trivial, its topology is non-trivial, which makes it will exist, but maybe cannot be detected by some kind of perturbation theory. And the interesting thing about this is the space-time is affected that it has the convex geometry due to the existence of it. The upper bound of the spontaneous global symmetry breaking has an upper bound of this value. This due to the Variola and Glenkin paper in 1989. It was shown also by Olafegasti in 2001 by modifying the metric itself into the one that has the deficit angle, that the contributions to the global monopole can be interpreted as the Ricci tensor components additional terms. The next is, if we go beyond this bound, which is this bound, right? We can see in another kind of in others literatures in 3 and 4 that there can be some kind of compactification solutions in there. It has cylinder geometry. If it is the boundary is like this, and the nonlinear model can evade the direct theorem, so that the dimension, the space-time dimension, can have an arbitrary dimension, not only as some kind of dimensional. Okay. The gravitational effect from this is investigated in 7 and many more, but in 7 it was investigated by mentioning that mass of the monopole can be positive or negative. Yet in the variable Glenkin, it was mentioned that the mass is negative, making the gravitational being repulsive. The above conclusions are from considering non-sigma model theory. We use here is the sigma model in using paper in by Blanco Filado and et al. And the difference is doesn't make any distinction to the conclusions before. This is the model. We have some. We define the actions to have this kind of Lagrangian density. This is the non-linear terms of the kinetic terms, and after we are interested in the solutions that makes this that have this kind of that is constrained to this kind, so that this term becomes the Lagrangian multiplier, and we use the metric spherically symmetric metric in 4-dimensional. We use the answer such as this to make it to satisfy the solutions to these equations of motions of the P. P is the scalar field. The scalar field is denoted by this vector, but it is constrained to this one by some kind of mechanisms, and only by using this we need this one to be satisfied. The gravitational field solution is as follows. By some kind of rescaling, we have this one. This is the deficit angle that is very different from the Minkowskian or the Schwarzschild solution. This is like a Schwarzschild solution, but when we plot it, we have some kind of if we plot it for lambda 0, we only have one kind of just one horizon, and if we zoom in, we can have, I think, yes, it is having two horizons, the inner horizon and the outer horizon. It can also have an extremal and have no horizon at all, which is negative singularity. If we have the lambda into something that is non-zero, we have more horizons, and by we also want to consider the external horizons, which is something like the core black hole, Naria black hole, and ultra core black hole. We plot it in the next. This is some kind of plot by adjusting the lambda and the beta. We can also see the parameter which is shown before in this solution, which is this the last term and the second to the last term. We can see it in analytical form such as this by using this, and these three parameters, these three constraints can differ the conditions for the each of the black holes, external black holes. The compactification solutions also being done by considering the compactification radius. It has this kind of constraints, which if we numerically see, it has this kind of hierarchy, which is less than the theta t, which is from the first one. And when we plug it into the omega, which is from this from the answer one before, we can have the compactification solutions also by this kind of metric, ES2, M2, and ES2, plus S2, or for all of them. And we have these constraints, which is when we compare it to the conditions before, we just have these channels of compactification. The conclusions as follows, but you can read it. Thank you very much for your attention.
Yeah, I'm calling for questions. No questions? And again, I have one. I'm just wondering about what actually we refer to as monopole, global monopole here. Because in my understanding, the term monopole arose at first when people considered magnetic monopole.
Oh, yeah.
So, what kind of monopole?
It is something like when you see X or something, because it's scalar, it's not vectorial. The expression is from the expression comes from here. The second which is scalar field, some kind of scalar field. Black hole solutions is kind of black hole. It's a global monopole, and it has some kind of deformation of some kind of thing about its horizon into two kind of horizons, something like that.
Does gravitational mass also fall into this kind of classification?
I don't. I currently not.
Because you just explained to us that from the consequence of the theory, it may imply that the gravitational mass can be negative. So that makes me wonder if mass can be part of what you mean by global.
We are currently not in that stage. We must unlike that mass also.
Okay. Thank you very much. And